Problem 550. Solve each of the following equations. Letter A, 3x over 5 equals x minus 2 over 4. Now there's a variety of ways to solve some of these equations. One thing you may want to consider doing, because we have a fraction equals a fraction on this one, you could do the whole cross multiplying method there, where you multiply this numerator times this denominator, and the numerator of this fraction times the denominator of the other fraction. You could also look at it as, hey, what number can we multiply by that would help to remove our fractions? In this case, what do 5 and 4 both go into a whole number of times? That would be the number 20. You can multiply both sides times 20. No matter how you start, you're going to end up with the same answer in the end anyway. So I'm going to do this one here with a little bit of a cross multiplication. So I'm going to say that I know that 3x times 4 so this one times this one should equal 5 times the quantity of x minus 2. I have to remember to put my parentheses around that because that's a quantity. So 3x times 4 gives us 12x. 5 times x would be 5x, and then 5 times negative 2 would be minus 10. Let's just go ahead and solve this. Taking away our 5x from each side, we're going to say there that 7 times some number equals negative 10. And if we do our division there, we get that x should equal negative 10 sevenths. Now, how could you check it? Well, you could take it and you can plug it back in. You can graph them on the calculator. There's several approaches you can take. For time's sake here, I already know this answer is right, so I'm not going to check it right this second, but maybe I'll be able to show you a way to check it before we're finished. Let's move on to B. Letter B, we've got 4x minus 1 all over x equals 3x. Now I need to get my variable out of the denominator for sure. So one approach I could take here is I could say, well, I want to multiply both sides of my equation times an x, because I got to keep it balanced. So when I multiply 4x minus 1 times an x and then divide it by an x, those are inverse operations. And that should leave us with 4x minus 1. And 3x times x should give us 3x squared. Now I have an x squared term on this side, and I have an x on the other side, which means it's quadratic. I can't solve it just by taking square roots because we have more than one x term. So we're going to have to set it equal to 0. Let's subtract 4x from each side. And let's add 1 to each side so that we'll end up with 0 equals 3x squared minus 4x plus 1. And let's look at solving that now. So 0 equals 3x squared. I'm just going to recopy. We know this is quadratic, so the first thing I'm going to check, does it factor? So I'm going to say 0 equals, and if it's going to factor here, since there's no common factor, we're going to say this would have to be a 3x. This would have to be an x. And our factors at the end are going to have to be 1 and 1, so hopefully this works. Got 1 here, we got 1 here, and these should both be minus. 3x times x, 3x squared. 3x times negative 1 is negative 3x. We'll just put that in there. Negative 1 times x is negative x. So when I combine those, I get negative 4x. And negative 1 times negative 1 is positive 1. Looks like we're pretty good to go. So use our zero product property. 3x minus 1 should equal 0, and x minus 1 should equal 0. Add our 1. We've got 3 times some number equals 1, which means that x should equal 1/3. Add our 1 to each side here. We get x equals 1. So we actually end up with 2 different answers on this one. X equals 1/3 or x equals 1. Now let's go ahead and let's do one check here so that you get an understanding of making sure that you know how to check them. So I'll pull out my calculator here. I'm going to clear out whatever I have inside my graphing menus here, my functions. And let's solve it as a system. Let's do 4x minus 1 over x. So if I was going to type that in, let's do it like I couldn't make the fraction mode on my calculator. So let's do 4x minus 1 in parentheses divided by an x. And our other side, we're going to have 3x. So let's move this over just a little bit. And let's graph it. That looks like I'll probably need to reset my window here. So I'm going to do zoom 6. Let's see here. So we see in here that it looks like it's intersecting. Now remember, you can do your zoom box if you want to get even closer there. Do one, move it up to, so it's just above where you want it. Then press enter, and it'll start to draw your box. That looks pretty good. I'm going to hit enter there. So now I can get up real close here and I can see just where it's intersecting there. There's one intersection, there's the other intersection. So let's just go ahead and do our intersect function, second trace, number 5. Let's move it a little closer to the one on the left. Enter, enter, enter. Intersection is 0.3 repeating. That's 1/3, so we know that one works. And let's do our second one. Move it a little bit closer to the other intersection point. Enter, 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 and you'll see the other intersection point is the 0.13, so that one also works. So remember, you can check it that way. All right, let's move on here. I don't want to lose you. So, letter C, we have 2x over 5 minus 1 over 3 equals 137 over 3. So this one, I'm going to look at it and say, well, I want to get rid of the fractions. Fractions are cool and all. I know you like them, but let's get rid of them here. So what number does 5 and 3 each go into a whole number of times? That would be 15. If you said 15, good call. Let's multiply both sides of the equation by 15. 15 times 2x is 30x. Divided by 5 would be 6x. And then 15 times negative 1/3 would be minus 5. 15 times 137 divided by 3, well, 15 divided by 3, first of all, would be 5, so it's like 5 times 137. If you want to pull out the calculator just to be safe and sure, that's fine. Go ahead and do that. So let's do 137 times 15, and then divided by 3, I get 685. So this should equal 685. Then let's just solve it for x. Add a 5, add a 5. So 6x equals 690. Divide each side by 6. So 6 goes into 690. That's what? 100, and then 115, I believe. So let's check to see if we're right here. So if I said 2 times 115, that's 230. Actually, you know what? Let's use the test function here. This is something else you may not be aware of on the calculator. So if we do, let's set our x value as 115. So 115 store as x. Press enter. So we now know that anytime I press x here, that means we have 115. And let's go ahead and build our equation here. Let's go alpha y equals, enter. I'm going to put in my fraction 2x over 5. And we're going to say minus alpha y equals, this is a fraction 1/3. And there's this function on the calculator for testing. If you go second math, you get this menu here. It has all your different inequalities and equalities here. Well, let's just go ahead and put in the equation. Let's say number 1. And let's go ahead and type in on the other side what we have. We have 137 thirds. So 137 over 3. And when you do this on the calculator, when you put in one of these symbols, okay, the calculator will go through and figure out what we have there, and it will either spit out a 1 if this is a true statement. Remember, our value for x is 115. Or it will spit out a 0 if it's false. So remember, we did second math to bring up that equal sign there. So we have that in there. So if we get a 1, that means we're good. And it was. See, 1 was true. So if we said, let's say 110, let's store that as x now. Okay, so now x is 110, which wouldn't be true then, right? So let's see here. To bring back up our equation, let's do second, enter, second, enter, to bring up what our equation was up here. And now that x is 110, it should give us a 0 because it won't be true. And you see that it does. It tells us it's false. Anyway, it's a little trick. Ask your teacher if you want to see more on that there. Let's go ahead here and let's do the last one. Letter D. 4x minus 1 over the quantity of x plus 1 equals x minus 1. Well, let's go ahead and get rid of our denominator. So our denominator here is an x plus 1, so let's multiply this side by the quantity of x plus 1. And then we're going to have to multiply the other side by an x plus 1. So that means that this and this will give us a value of 1, leaving us with 4x minus 1 over here equals, and let's go ahead and multiply these two binomials together. We've got x minus 1 times x plus 1 which if you do your generic rectangle or you FOIL, you should see that it gives you x squared minus 1. Now, because we have more than one x, we're going to have to set it equal to 0. And where did my cursor go? There we go. Sorry, it disappeared on me. Let's add our 1 over here. So what we're going to end up with here is 0 equals x squared. We have minus 4x, and then negative 1 plus 1 is going to give us 0. So 0 equals x squared minus 4x. Let's rewrite it. And to solve this, let's look at factoring first. Is there a common factor between x squared minus 4x? There certainly is. Let's factor out the x, and we've got x minus 4 left. Use our zero product property, which means that x could equal 0, or x minus 4 could equal 0. Solve each of them. Well, this one's already solved. We add 4 to each side here, we could get x equals 4. So we have two possible answers here. X equals 0 or x equals 4. Now when we go back up here and we look at this, what's the only value that x cannot equal that would make this an invalid statement? That is if x was negative 1, and since we didn't get either of those there, neither of these are a restricted value, we are good to go. So that is our answer, x equals 0 or x equals 4. Here's just a real recap of our other answers. X was 115, 1/3 or 1. And as we move all the way up to the top, x equaled negative 10/7. This is problem 5-50. This is Mr. Boyd. Hopefully this helped you.